Hi guys, so what we're going to do today is we are going to continue solving quadratic equations, and we're going to look at two more methods in order to be able to do that. Now a lot of this is going to be review from Algebra 1, so hopefully it's not going to be too bad for you guys, but we're going to have to see some other methods besides just factoring. Now factoring to solve a quadratic I think is the fastest and probably the best method. The problem with factoring though is that it only works when your zeros are rational. So if you remember that big chart from last class, rational numbers are the ones that can be written as fractions. So like 7, -4, 2/3, 1/2, those are all rational numbers. So if those are your zeros, factoring is going to work. But if you have complex or irrational zeros, so something like 2 plus the square root of 3, negative square root of 4, well not square root of 4, sorry, negative square root of 6, 3i, 2 plus 4i, any of those types of solutions, we need a different method. So we're going to save one of those methods for next class. Today we're going to focus on solving by square roots and solving with the quadratic formula. So in order to solve by square roots, this is actually a pretty easy method, but again one that only really is best in certain cases. This method works best when your x is only in a squared situation. So what I mean by that, if you look at these x's in each of these four problems, okay, that x only has a squared x. So what we don't have is like another x that's over here or another x that's over here. The only x you have is being squared. Whether that's by itself, like these two, or in parentheses like these two, that's your only x, and that x is being squared. So this is the case when the square root method is going to be the fastest. And what we're going to do is we are going to get the squared term by itself. So what I mean by that is we are going to get this x squared, or the part that's in parentheses, by itself. And to do that, we're really just going to solve these equations very similar to how you first learned how to solve equations. So think about how you solved this equation back in maybe even 8th grade. Okay, you would have added 3 and divided by 2. So we're going to do the same thing here to get x squared by itself. So add 3, divide by 2. Once you get to this point, to solve for x, you would square root it. Now remember, when you square root though, the answer to this question is not just the square root of 5. It's plus or minus the square root of 5, because a negative square root of 5 squared is also 5. All right, let's go to our next one. Again, same idea. We're going to solve this equation the same way we would solve this equation. We're going to add 10, and then we're going to divide by 3. So what we're going to do, again, add 10, and then divide by 3. What you need to make sure about that you do not do, we cannot distribute that 3. And that's something some people want to do sometimes. That does not work because that is not 3 times 2x minus 5. Okay, if it's 3 times 2x minus 5, yeah, go ahead. If you want to distribute, distribute. The problem is this is 3 times 2x minus 5 times 2x minus 5. So if you were to distribute that there, you would get 6x minus 15 squared, which is 6x minus 15 times 6x minus 15. That is not the same thing as this, which is what we actually have. Okay, so moral of the story here, do not distribute that number if you have a squared here or a cubed there or anything else. You can only distribute if you have just regular plain old parentheses with nothing else. Okay, so going back, we'll go ahead and divide by 3. Then at this point, what's squared is by itself. So all you have to do at this point then is square root. So it's going to be the same thing we just did, except we're not quite done. We're going to have a couple other steps. So the square root of 9 is both plus or minus 3. And then let's solve again to get x by itself. So we're going to add 5. And we're going to divide by 2. Whoops. Let me write this over here. There's some more space. Okay, now at this point, we really don't want to leave it in this form. This isn't very simplified because we can actually figure out what these numbers are. We can actually do 5 plus 3 divided by 2. 5 plus 3 divided by 2 is 4. And I can do 5 minus 3 divided by 2, which is 1. So those are my solutions, and that's how I want to write them. So again, if you can simplify, you want to. All right, so if you feel comfortable, pause the video, try these next couple on your own. All right, so looking at this next one, again, our goal here is going to be to get this term by itself, and then we'll square root. So I'm going to subtract 5, divide by 2, square root. Now the square root of 8 can simplify to 2 root 2, so I'm going to go ahead and do that. Then my next step would be to add 4 and divide everything by 3. And at this point, you can leave your answer in that ugly form because that is as simplified as we are going to get. All right, looking at the next one. Again, we want to get x squared by itself. So we're going to subtract 15. Divide by 3. And then this is why we just did complex numbers. So now at this point, we're not going to stop and just say there's no real solutions. We're actually going to find those complex solutions. So when I square root it, remember it's plus or minus, and remember a negative inside the square root becomes an I outside the square root. So we do have 2 solutions here, they're just imaginary. All right, one more. Again, if you feel comfortable, pause the video, try this one on your own. We're trying to get this part by itself, so I'm going to subtract 13, divide by 2, square root both sides, and this is going to be plus or minus the square root of negative 4. The square root of negative 4 is 2i. Add 2, divide by 3. Now the format you want to do, it's up to you. If you want to leave it in this form, that's totally fine. If you want to rewrite this in that standard form, that a plus bi form, that's also okay. Either of those is fine. All right, so that's solving by square roots. So again, just a couple things to make sure about. Do not distribute something that's on the outside there if you have a squared term, okay? Can't do that. Again, this method works best when the only x you have is being squared. So now we're going to go to typically the student's favorite and my least favorite method for solving quadratics, and that is the quadratic formula. The nice thing about the quadratic formula is that it always works. You can use the quadratic formula for every single quadratic you ever have. The problem is that if it's not the best method to use, it's slower and it's easy to make some mistakes because you've got a lot of little algebra steps within here. That's one of the reasons I don't really like it, because there's usually a better method to use, especially if you can factor. Don't use the quadratic formula if you can factor. Now the quadratic formula, if you do not remember, is written over here. The way I've always taught it and the way I always learned it was to learn it to the tune of Pop Goes the Weasel. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. So remember your a, where the a comes from, I don't know why I wrote a squared, it's ax squared plus bx plus c. That's the a, b, and c values that we're going to use. So the coefficient of the squared term is a, the coefficient of the x term is b, the coefficient with nothing on it is the c. Something else that we get from the quadratic formula is something called the discriminant. So the discriminant is the part that is under the square root. And what that does is that gives us information about our solutions, depending on what that discriminant is. So if what's under the square root is a positive number, we're going to get 2 real solutions, which means this graph is going to have 2 x-intercepts. If that discriminant is exactly equal to 0, there's only going to be one solution and one x-intercept. Specifically, that intercept is going to be the vertex. And if that's negative, okay, the square root of a negative number, it's going to give us imaginary solutions. So we'd have 2 complex solutions, which means that you would have no x-intercepts. So if you just want to know information about your solutions without going through the whole process of finding what they are, using that discriminant that's under the square root of the quadratic formula can help give you guys that information. All right, so again, if you remember this from Algebra 1, I would pause the video and go ahead and try these 2 on your own, because the quadratic formula is something that you guys probably remember. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'll simplify what's under the square root. That's going to be 64 plus 16, which is 80. And I'll tell you right now, the biggest mistake with quadratic formula doesn't come from remembering what it is, it comes from simplifying. And there's 2 very common simplifying mistakes. The first one is right here, seeing this in this form and saying, okay, good, this is negative 4 plus or minus the square root of 80. That is not true. You cannot do that, okay? The other thing that happens is you take, okay, well, let me divide both of these things by 2. And you rewrite this as -4 plus or minus the square root of 40. Okay, that is also not true. The only way to divide that square root is if you're dividing by another square root. So don't divide it by a regular number. That doesn't do anything. What you have to do here in order to simplify this is simplify that square root first. Then, if you have a number here, and both of those numbers are divisible by the same thing as the bottom, then you can simplify. So square root of 80 is divisible by 16. So I can divide out that 16, which becomes, when I take the square root, 4. 80 divided by 16 is 5. And now I can simplify. All 3 of these numbers are divisible by 2. So I can divide all 3 of those numbers by 2. And I get -4 plus or minus 2 root 5. All right, let's try this next one. Again, if you feel comfortable, pause the video, try it on your own. So b squared minus 4ac all over 2a. So this becomes -20 plus or minus the square root of, that's going to be 400 minus 8. So 400 minus 8, that's going to be 392. Now, I don't know the square root of 392 simplified off the top of my head. I can't really think of anything that divides from it, so I'm going to go ahead and use a factor tree on this one. So 392, let's break that down. It's an even number, so it's divisible by 2. So that's 2 and 196. 196 is an even number, so that's divisible by 2. So that's going to be 2 and 98. 98 is an even number, that's divisible by 2. 2 and 49. 49 is 7 and 7. So looking at all those bottom numbers, I've got a pair of 7s and a pair of 2s with the 2 left over. So on the outside, I'm going to have a 14. On the inside, I'm going to have a 2 left over. So now I have that square root simplified. At this point, we can simplify. All 3 of those numbers are divisible by 2. So I'm going to divide all 3 of those numbers by 2. And I get my final answer. All right. Again, if you feel comfortable, guys, keep trying these on your own. You really just need the practice to make sure you really know quadratic formula. But I will tell you, if you're trying these on your own, both of these are going to give you imaginary answers. All right, so let's try this next one. Before we solve any of these quadratics, okay, an important step you need to make sure you take, we have to set it equal to 0. So in this case, we can't just jump into the quadratic formula because what the quadratic formula is telling us are the x-intercepts. It's telling us the zeros. We can't solve if it's not actually equal to 0 because that's what we're trying to find. Otherwise, you're saying when does this equation equal 4? Okay, so you would say when, not just what the x-intercepts are, you'd want to know when it crossed that point. So in order to use quadratic formula, it has to be equal to 0. Now we can go ahead and solve this. So I get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So that gives me 4 plus or minus, that's going to be 16 minus 4 times 13 minus 52. That's going to be a -36. And then again, complex numbers. Now don't simplify this yet. Okay, simplify your square root first. That's going to be 6i. Both of those numbers are divisible by 2, so that becomes 2 plus or minus 3i. All right, then last one, and again, same thing. Got to set it equal to 0 first. So 2x squared minus 2x plus 1 equals 0. So -b plus or minus the square root of b squared minus 4ac all over 2a. So 2 plus or minus the square root of 4 minus 8 is a -4. -4, 2i, so plus or minus 2i over 4. So that gives me either two ways you could write this. We can write this as 1 plus or minus I over 2, or we could write that as 1/2 plus or minus 1/2 I. Whichever way you want to write it, it is up to you, as long as you make sure you don't simplify these numbers before you simplify the square root. All right, so one last question we're going to look at, and that is really just a word problem involving a quadratic. So this one, we might want to draw a picture here. So it says each side of a square is decreased by 2 meters in order to make a square with an area of 72 meters squared. So here's my side. That side is decreased by 2. It's giving me an area of 72 meters squared. So that means to find area, I would take that side and I would square it, and it's going to give me 72. So to find the original side, all I gotta do is solve this equation. This one's gonna be easiest to solve by square roots because the only x you have is being squared. So let's square root both sides. The square root of 72 can simplify. 72 is divisible by 36, so that 6 can come out. I'm gonna add that 2 to the other side. That becomes 6 root 2. Now, let's think about our problem that we have. Okay, if I did 2 minus 6 root 2, okay, the square root of 72 is bigger than 2. Okay, we don't have to know exactly what it is. We know it's bigger than 2 because the square root of 4 is equal to 2. So if I did 2 minus the square root of 72 or 2 minus 6 root 2, that's going to be a negative value. Negative value would not make sense for this problem. So even though there's 2 answers algebraically that work, there's only one answer that actually makes sense for this problem, and that's 2 plus 6 root 2. Now, if you want to find this an estimate for this using a calculator, you're welcome to. But if you have no calculator, then this is your most simplified answer. All right, so that is it today for solving quadratics. We're going to look at the last method next class, which is solving by completing the square.